How y'all doing? Pretty well. And the Oscar for Best JavaScript Framework and Motion Picture is... welcome to EmberConf 2018. This is our 5th anniversary, and we could not be more excited to be here with all of you today. We have a lot to cover, so let's just dive right into it.
I'm very happy to announce that MELANIE SUMNER is joining the core team. MELANIE has done great work modernizing the Ember website to make it more accessible and generally making accessibility a front and center concern across the entire project. And as a JP Morgan Chase employee, she has also served as a tireless representative of the many Ember developers working inside of large enterprises, and so I'm very excited to have her join the team.
So, yeah, MELANIE. All right. So this is the 5th anniversary of EmberConf, and there was an EmberCamp before that. But Ember itself is 7 years old in April. And we've always described Ember as being a framework for creating ambitious web applications. It's even the first thing you see on our homepage, but there's maybe an even better way to say it. I think for me, Ember is really for ambitious developers. Ember is not really the code, which has changed radically over the last 7 years. Instead, I think the defining feature of Ember has always been our community.
And if you're an Ember developer, it's because you value productivity over endless tinkering, you value shipping features over rewrites, and you believe that we can solve problems better by solving them together as a group because your app is not a special snowflake. And you also know the value of our community moving together as one. To us, those ideas seem like common sense. We've always thought that we always thought of them, but they run counter to a lot of the conventional wisdom of what the JavaScript community thinks today. Over Ember's 7 years, our community has come together to build a cohesive set of tools that are designed to last. There's nothing else like it in JavaScript, honestly, and one of the benefits of being an Ember user is feeling confident that even as the web changes, your tools are kept up to date and tested to work together.
And it goes beyond the framework itself. We have this huge ecosystem of add-ons that extend Ember while preserving that same belief in stability and productivity. So the truth is that we really love Ember. We're proud of Ember. And so when it came time to think about what our focus should be for the future, it was obvious. We don't want to change the fundamentals. We just want to build a better Ember.
So that's what the focus of the 3.0 series is going to be. Together, we're going to build a better Ember. Fundamentally, there are 3 broad themes that we've heard people say they want us to focus on, including most recently in the survey that you should check out. So the 3 themes are, first of all, we want to reduce the number of concepts that people have to learn to start feeling productive in Ember. Second of all, we want to take advantage of new features in JavaScript as they start to land in browsers. And third, we want to give people tools to be even more successful. Our APIs should help people fall into the pit of success. But we can't do it ourselves. If we want to make this happen, we really need to rally the energy of everybody in this room, the whole community, to make this work.
So today, I want to share with you our vision for what using Ember in 2019 could be like. By knowing where we want to go, together we can figure out the best way to get there.
So the first thing that we want to see is clear, more conventional file system layout that replaces both the default file system layout and what a lot of people are using, the experimental pods layout. As a community that prides itself on conventions and shared solutions, it's time to roll the learnings from the pods experiment into the default Ember experience. In the current default file system layout, components and their corresponding templates live in 2 different directories. As you know, the process of switching from one to the other in your editor can be tedious and error-prone. And as your app gets even bigger, this can lead to a lot of annoying scrolling just to switch from a component class to its template. So in the new layout, heavily inspired by pods, we want to keep related files next to each other. Not only does this make switching back and forth easier, it makes the structure of the entire application clearer. And best of all, thanks to Ember's strong conventions, we could build tools to painlessly migrate existing apps to the modernized layout. I really, really love code mods, and I love that both the JavaScript community and the Ember community has gotten interested in them.
So speaking of modernization, let's talk about jQuery. Ember 1.0 supported IE7, and actually the test suite passed in IE6 too, on accident. And those were popular browsers at the time. In that era, we needed to work around the large number of cross-browser quirks, and jQuery was the best tool to do that. However, more and more people are building Ember apps that are using just the native DOM API. For example, this component doesn't use jQuery at all, and instead it uses the native query selector method to first find a child iframe element, and then use the post message API to send a message to it. And in fact, ever since we moved to the Glimmer VM rendering engine, Ember itself hasn't used jQuery at all in the view layer. And we're big fans of jQuery. We think it's the right choice for many apps. But at the same time, we want to be as approachable to new developers as possible. And we really don't want people to think that they have to learn jQuery just to be able to use Ember. And it may surprise you to learn that jQuery is one of the largest contributors to Ember's default file size. So jQuery is over 30K, but it's over 30K even after minification and gzip. So if we could make jQuery optional, the out-of-the-box file size of an Ember app would drop by 1/5.
So testing. To write software that lasts, you have to have tests that give you the confidence to make changes. Every new Ember app comes with integrated end-to-end testing infrastructure, and our community has a fantastic testing culture. I really love testing in Ember. It's really great. But we can make tests even better by taking advantage of new JavaScript features like async functions. And we can make it even easier for people who want to use testing libraries like Jest or Mocha instead of QUnit. The first thing we can do is actually related to jQuery. In my own app, we don't use jQuery that much in our components, but it's still very common in our tests. And this is true about a lot of apps that I've seen. It would take, in many cases, more time to migrate tests to stop using jQuery than app code. So step one is to transform all the places that we use jQuery in our tests to use new helpers that use native DOM APIs. And step two is cleaning up our tests to use async functions. Often in tests, you want to write code that relies on asynchronous tasks finishing. And this code can be difficult to read and write in JavaScript. So our existing test helpers are asynchronous by default. And we introduce the and then helper to wait for asynchronous code to finish before moving on to the next part of the test. However, now that JavaScript has async functions, we have a built-in way to tell a function to pause until some asynchronous task has finished. So if we make all of our test helpers use return promises, they would work seamlessly with async functions. So in this example, we turned the test on top into an async function. And because the test helpers in this example return promises, we can use await to wait for rendering to finish before continuing with the test. And that means that we handle asynchrony the same in our tests and in our application. And best of all, I love code mods. We can help the community move to this better way of doing things by using a code mod, which can update a lot of tests automatically to use async functions and migrate tests using jQuery to the new testing helpers. And finally, in the testing topic, while we're on the testing topic, although we personally are big fans of QUnit, Ember is a big tent, and we want to work with whatever testing frameworks people prefer. And so by simplifying the API, we can make integration with other testing frameworks like Mocha more reliable and first class.
So Ember was an early adopter of JavaScript modules. In fact, Yehuda helped drive their design through TC39, and Ember CLI has used the module syntax since before Ember CLI 1.0. So this is what a typical file looks like in an Ember 2 app. Each file is a module, and then Ember itself is exposed as this single module with everything on it. And this works, but the beauty of JavaScript modules is that they let you import just the things that you actually need in that one file. And we want Ember users to be able to import just the parts of the framework they need. So in this small example, it maybe doesn't seem like much of a difference to use a JavaScript module API. But in more complicated files, the monolithic global hides the fact that Ember is made up of a bunch of separated packages under the hood. So this leads people to feel like Ember is overwhelming to learn. It's doing too much. And your API is how people think about your library. So this overwhelming API leads to documentation that has also felt overwhelming. So even though you only, in practice, need a handful of concepts day to day to write an Ember app, this overwhelming list was the first thing people would see when they went to get help. So this is typical reaction to the API docs. One of the best benefits, in my opinion, of JavaScript modules is that it allows you to orient your API documentation around these different packages that we're already using internally. And they're naturally grouped by functionality. This makes finding documentation easier, as well as giving people a much better intuition about what your framework actually does. So we can replace this big old list of classes with these packages that tell you exactly what they do. Now, you might imagine that going through every file in your app and refactoring it to use the module API would be tedious and time-consuming, and I agree. If you had to do it by hand, you would be right. But again, the best part about this feature might be that we can fully automate this process. In fact, going forward, anytime Ember changes something that requires these kind of sweeping changes, we should really create a code mod to help you migrate. In addition to the learning benefits, modules also unlock the ability to produce better optimized apps. We can detect when you use debugging utilities, and we can ship them automatically from production builds. And we can also use tree shaking, analyze the module graph, and include just the parts of the framework that you actually use in the compiled output.
One thing that we really want to see in next year is great integration with editors. Getting feedback as you type reinforces good patterns and makes learning faster. For example, if you moved your app to the new JS module API that we just talked about, it would be easy to fall back into old habits and use the old API. But if we offer great editor integration out of the box, we can catch this right away and give you a warning right there in your editor. And we can also take advantage of the fact that Handlebars is a first-class programming language and build first-class tools on top of it. In this example, our editor is able to automatically discover and suggest the name of the component as I'm typing it because it understands Ember's file system layout. Ember is made up of many individual packages, but pulling all these pieces into a single integrated editor experience would give users something even greater than the sum of its parts.
Ember's object model is the heart of the framework. Everything else builds on top of this foundation. So improvements that we make to the object model oftentimes can unlock many downstream improvements in other APIs. So let's first look at computed properties, which are perhaps the most popular feature in Ember's object model. So ES5 added a syntax for computed properties. But when Ember first came out, ES5, as hard as it may be to believe, was not available in many of our supported browsers. And if you think about how many computed properties you use in your apps, I think you'll agree that it's hard to imagine us not having this feature. So we had to create our own computed properties using the features that were available to us in ES3. That said, we noticed that forgetting to use .get trips up people as they learn Ember. It feels really frustrating every time you forget until you kind of develop the muscle memory to use it everywhere. So what if we could stop requiring the use of .get? This would make Ember so much easier to learn for people who already know JavaScript. It would also mean that Ember's computed properties work with a new language syntax like destructuring because they would just be normal JavaScript properties.
So another feature that exists in JavaScript today that didn't exist when we first started Ember is classes. ES6 added a new class syntax to JavaScript. This is a simple example of a person class that has a first name and last name property and a method called sayHello, which is the example as required by law. So let's try to take an ember.object subclass and rewrite it using native class syntax. So first, we're going to move everything in the init method on the left side into the constructor on the right side. Now, classes don't support, in ES6, classes don't support initializing properties directly, so we will need to set the title property inside the constructor on the right side. And next, we're going to move the didInsertElement method, which is a pretty straightforward transplant from the left to the right side. And finally, we are going to move the tab count computed property, but wait. Oh no. So what's the problem here? The problem is that at TC39, we intentionally shipped a maximally minimal class syntax in ES6 to get started, and it's missing important features needed to migrate the richer Ember class model to standard classes. There's no way for us to express things like computed properties directly inside of the class body. But good news, TC39 did not stop with max-min classes, and we have been busy adding important features based on developer feedback. So decorators are a proposed new feature that allows developers to implement features like computed properties inside of class bodies. And let's take a look at how we would finish this port using decorators. So in this example, we have a computed decorator. And with the computed decorator, we can say that this getter is now a computed property and tell Ember what its dependent keys are. While we're at it, let's get rid of the unnecessary .get from the tab count implementation. And finally, now that we have decorators, we can move the service declaration from the left side to the right side. I think it looks pretty nice. So isn't this slide beautiful? I've personally been waiting a long time for classes to get to the point where we can put this slide on the screen. And I'm happy that TC39 has finally almost gotten all the features together to make this possible. Yeah.
But decorators aren't the only improvement coming to classes. In the previous example, we had to move initializing the title property out of this nice declarative syntax in the Ember version into the constructor, which is something that the first iteration classes don't allow you to declare class fields in the body, the class body. However, at TC39, the class fields proposal gives us the ability to declare and initialize properties with a convenient syntax that is quite similar to the Ember syntax. And all of these features together add up to a really nice experience for Ember developers who want to use TypeScript. JavaScript classes, if we had them, would make it much easier to adopt TypeScript in your app. With class fields, we can tell, we have now a place where we can tell TypeScript the types of our current user and tabs properties.
We think that people in general should be able to get a great Ember experience using TypeScript, but as always, we will always design the Ember APIs JavaScript first, and we would never make TypeScript mandatory or make any part of the Ember runtime rely on TypeScript support. And actually, a lot of people who like TypeScript really appreciate that we have this philosophy. One of the things I really love about TypeScript is the detailed autocomplete it brings to your editor. Especially if I'm writing code that relies on another file, it's really helpful to be reminded what properties and methods are available as I type. So if I'm writing a method in my component and I need to get some data from another service, I don't have to switch files to see what this property is called. TypeScript shows me right there as I type. And actually, if you're thinking, oh, I don't use TypeScript, so what do I benefit from this? JavaScript users benefit when Ember uses TypeScript more, because editors can use TypeScript information to provide autocomplete and inline documentation, even in JavaScript files that don't use TypeScript. So, no. Demo faux pas, never go back, only forward. So that was all the object model. Components are one of the most fundamental APIs in Ember. So because of how important components are, making components better yields a huge payoff. So let's continue with the theme of simplifying Ember to talk about what people call fragments. One property that you're probably used to from Ember components is that they add a wrapping DOM element around the component template. This element can interfere with CSS rules or just make the DOM more complex for a little benefit. And one thing that I should mention is that power users were always able to disable this behavior. So probably a lot of people in this room know that there's a trick that if you set tag name to empty string, it removes the wrapping element. But it really sucks that having to create an empty component class just to do this, and it really breaks the flow of learning Ember at a particularly early point in the process. So to make this more discoverable, we really want components without a class implementation to not get their template wrapped in an extra DOM element. And what this change does is it makes creating reusable snippets of HTML feel incredibly lightweight, and it's more intuitive because templates become what you see is what you get in the DOM. Yeah. It's also annoying that you have to create a component class just to customize the wrapping element. If I want to replace the default div with a field set element, for example, Ember developers have to create a new component class and learn a new JavaScript API for changing the tag name or binding an attribute. And this isn't ideal because these are both things that people intuitively already know how to do in a template. So with fragment components, we can delete this component class and just put the field set element in the template where it belongs.
So we talked about no longer requiring people to type this.get everywhere, but you are probably wondering, well, what about this.set? For Ember to be able to keep the DOM up to date for you, it has to be able to see when your component changes, when you change a property on it. And currently, we do that by asking you to call this.set. But if we had class fields, and if we had the track decorator, we could tell Ember about the property once, and then set the property like normal everywhere else. So in the class on the right, I tell Ember that the title property is tracked, and then when I mutate it in the update method, I don't have to worry about calling this.set. It already knows what to do. So how do tracked properties relate to computed properties? You might be thinking, well, we can just rename to computed to tracked, and it would behave the same as before. And if you've used Glimmer.js, you know that this works. In fact, it's what Glimmer.js does. But what if we could do better than that? With tracked properties, we could automatically infer its dependencies on other tracked properties just by you accessing them right there in the function.
Yeah.
Imagine never having to think about writing dependent keys again, or keeping them in sync with the implementation. This would be such a massive productivity boon, and it would eliminate a common source of bugs that bite even me. Tracked properties would make auto-tracking dependencies like this possible.
That's what you get for experimental switch controller.
My Joy-Con has died.
So that's really awesome. I'm really excited about that. One issue that people have with the component API is that it's hard to tell whether properties are coming from the component itself or passed into arguments. I think everyone in this room has written a lot of components that look like this. Can you tell by looking at this code whether show comments is passed in as an argument to the component or whether it's a property on the, whether it's meant to be a state on the component? Well, actually, neither can we. The only way to know for sure is to search the code for all the places where the component is used to see if anyone passed in a show comments argument, and I've done that a lot of times. So to make things clear, what would be better is if components get their arguments off of this.args in JavaScript, and by using a special syntax, @name syntax, in their templates. So here's the same component updated to be more explicit. It's much easier to see that post is an argument, while byline and show comments come from the component. And this also bakes in and finalizes the data down actions up pattern right into the API by making the passed in data immutable. So if we put all these improvements together, the code for a real-world component gets much simpler and cleaner. Here's an example from the app that you build in the Getting Started tutorial called Super Rentals. So component state is more obvious because we mark it as tracked. Component arguments are more obvious because they come from the args property. Async code is cleaned up with async functions, and we have moved the class name from JavaScript into the template. Now everything DOM related is in the template where it should be. So that was quite a whirlwind tour. And each of these features alone might seem small, but having used many of them in Glimmer, they really do add up to something great.
So this is our vision for Ember in 2019. New features that simplify, clarify, and help you be even more productive. But do we really have to wait until next year's EmberConf? If you look under your chair, you'll see we've printed out a download. No, I'm just kidding. Everything that we just talked about as being our vision for the future of Ember is already here. Everything that you saw is a feature that is already on stable, beta, or canary releases of Ember today. And many of the people who are here in this room have helped to make that happen. So if you are as excited as we are for this vision that we just presented, we really need your help to get everything into a stable release. If you haven't contributed to Ember before, now is a great time to start. You've all already done such amazing work to get us to this point, but we have even more that we want to get done. Our lawyer, Robert Jackson, insisted that we add this disclaimer. The things we were about to show you are not finalized yet, so everything here is subject to change.
So we've already covered a number of features that came from Glimmer.js and have already landed in Ember. One thing Glimmer.js users have told us is that they really love the so-called angle bracket syntax. People who use this feature in Glimmer.js said they were really surprised at how much clearer it made their templates. So here's what using a component looks like today in an Ember application. And here's what the same component looks like using angle bracket syntax. For me and for other people who have used Glimmer.js, it really helps to distinguish between control flow structures and components in applications. And the icing on the cake is that you can finally use single-word component names.
Yes!
Keen observers might have noticed that the @ syntax in the component invocation is the same as the @ syntax in the templates that we showed before. That isn't an accident. When using angle bracket syntax, the names on the outside line up with the names on the inside. In other words, the @ is how you talk about arguments both on the caller side and inside of the component's template.
So since Ember 2.3, you have been able to yield components to a components block. People have really taken to this feature, implementing all kinds of cool patterns. One thing that we've seen a lot is to use this feature to basically allow users to pass more than one block into a component. And one of the principles of the Ember community is that we make sure that these common patterns are available to everyone, not just the power users who figure out the pattern. So we're working a way to bake this pattern right into Ember. So RFC number 226 introduced the concept of named blocks. These allow you to pass in more than one block to a component. So in this accordion component, for example, in addition to passing in an array of items as an argument, we are also passing in two named blocks, one called header and the other one called details.
And the best part of this feature is how easy it is to define components that use named blocks. If you have written one that uses the current API, you know that it really is a power tool. So at the top, we have our component template that invokes the blocks that were just passed in. And in this RFC, they're just arguments, just like @items is. So these two features have not landed in Canary yet, but they are already RFCs. The name blocks RFC has already been merged, and the angle bracket component RFC is still active. Please check it out and help us get it merged so we can start moving it into Canary. And there were even more RFCs that I wanted to talk about today, but I was told we only had 3 hours. Tom made me add that joke. Overall, it really feels like we've found a rhythm for shipping code while keeping the pipeline of ideas full. I'm really excited about what we're building together. Really excited about what we're building together.
Yes!
Yes!
So last year, speaking of, we announced Glimmer.js. And we started by taking this small core of functionality that we had extracted from Ember, and we built out this streamlined toolchain for building lightweight web applications. Now, we already talked about some of the great ergonomic improvements that were inspired by Glimmer.js that are making their way back to Ember. But of course, Glimmer is also about performance. So I spent some of last year using Glimmer on an exciting performance-related project at LinkedIn. You may have read the blog post. So the feed you see when you log in is powered by Ember. But for this experiment, we rebuilt this page with initial load time as the only constraint. But instead of rebuilding it once, we did it twice.
How crazy is he going to get?
A small team of engineers rebuilt the feed in both Glimmer.js and Preact, which we called the two different flavors. And we used Preact because at 3 kilobytes, we considered it to be the gold standard for building lightweight pages, and also for how easy it is to hand tune to achieve optimal performance. It also helped that we had one of the maintainers of Preact on the team. Definitely swayed the decision a little bit. Both flavors rendered their initial HTML on the server-side rendering. And then they would rehydrate the application in the browser. Now, we ran these two flavors in production for a week to see how they compared. And to measure how fast the page loaded, there were two numbers, really, that we looked at. The first one is first meaningful paint. The first one is first meaningful paint, and the second is rehydration time. So first meaningful paint measures when the primary content becomes visible and the page is ready to read. You can scroll, and you can start tapping links. And then rehydration is when the JavaScript app has finished loading. It's up and running in the browser. It reconnects to the DOM. And in practice, this is when the app is fully interactive, including, in our case, things like the share button and the like button. So how did we do? Well, both flavors performed extremely well, delivering first meaningful paint in both cases under 3 seconds. And both implementations also finished rehydrating around the same time. So both libraries are a great way to build fast, lightweight pages for the modern web. We were very happy to see Glimmer perform so well that it could keep up with libraries like this that are built for speed.
Yeah. Good work, Tom. So as Tom was working on the application inside of LinkedIn, I was helping the cause by optimizing the Glimmer VM. And there are really a few features that we worked on that contributed to Tom's great results. First of all, compiling templates into binary data reduces the time spent parsing JavaScript. Server-side rendering allows users to see meaningful content before the app has finished loading. And finally, incremental rehydration allows apps to start up without causing jank. So first of all, we improved performance by compiling our templates into a new binary format called GBX. Not only does this allow us to do more work ahead of time, it also allows us to reduce the size of Glimmer and speed up the execution of the templates themselves. And this feature is already in the Glimmer VM and is already available to Glimmer.js users. The second contributor to Glimmer's performance is async rendering, which means that the rendering work can be split into chunks and spread out over multiple frames, allowing the users to see content more quickly while the device remains responsive. This is especially important on mobile devices where the CPU can be overwhelmed by the demands of the modern web. I could describe the details of how it works, but all you probably need to see is a comparison of a Glimmer app running on a low-end phone, one with async rendering and one without.
We're going to be here a while.
It's like many Wikipedia pages is the demo.
So,
yeah. Good work, async rendering.
To hit our very ambitious performance goals, we assumed that we would need to use server-side rendering. Now, Glimmer's VM architecture already decouples the rendering pipeline from the DOM, so all Yehuda needed to do was re-implement a new renderer that used the existing nodes instead of creating new ones. Now, there has been some debate in the wider JavaScript community about whether server-side rendering is really worth it. So as a result, we also ran both of the Glimmer and Preact flavors using server-side rendering and client-side rendering. So as you can see, we managed to deliver content to the user a full 1.5 seconds earlier when rendering on the server. First meaningful paint is measuring when the user can read content, click links, right? It's such a meaningful milestone to hit during the load of the page. And rehydration is great, but if the user has already started scrolling or interacting with the page, we can't afford to lock the browser for a few seconds to do the rehydration. So what's really cool about how we do rehydration is that the same async rendering engine that you just saw that powers incremental rendering also allows Glimmer to perform rehydration without janking the scroll if the user starts scrolling on their device.
Now, one problem that people have run into with server-side rendering is that small differences between the server and the client can lead to surprising performance problems. It's nearly impossible to produce identical renders on the server and client due to even small things like small differences in things like internationalization differences across browsers. So in our implementation, rather than assume that these kind of differences are bugs for app developers to fix, we wanted to be able to repair differences between the server and client automatically. And I think that was a great improvement of our implementation. And not only has this change made it back to Glimmer.js, it is actually already available in Ember Canary. In fact, this year's EmberConf scheduling app is an Ember app using rehydration. So definitely try it out on your phone and see how fast it feels. Yeah.
Thank you to 201 Created, who created this app, and you, the real MVP.
See.
So those are some of the really great performance advancements that we've been working on in Glimmer.js. And we're looking forward to bringing them to all Ember developers soon. So today, we've shared with you just some of the awesome new stuff that's coming to Ember. We've talked about ergonomics improvements, talked about performance improvements. I feel a renewed sense of momentum in our community, and I have never been more excited to be an Ember developer.
But there is one more thing. Glimmer is our laboratory for audacious experiments where we can take advantage of the most cutting-edge web technologies. The web is always evolving, but every once in a while, a technology comes along that feels like a sea change. And there's something I've been working on for the past few months that I'm really excited to talk about with you today. If you aren't familiar with what WebAssembly is, it's a way to run code at native speeds in all modern web browsers. While JavaScript can sometimes achieve close to native speed with careful attention and hand tuning, and believe me, I know, it is hard for even the best JavaScript programmers to get good performance predictably. And we've managed to build a very fast VM using JavaScript, but maintaining good performance in the face of ever-changing JavaScript JIT optimizations across 4 different browsers and then some has been extremely challenging. So needless to say, the promise of WebAssembly got us very excited. But the first question is it even possible to adopt WebAssembly in a library architected years ago for JavaScript? So last year, as WebAssembly began shipping in all browsers, we got interested in exploring whether we could take advantage of this new capability. Due to its nature, Glimmer has always been written in a low-level style, the style that we had to do to hand-tune to make things fast in JavaScript. And we looked at it, we were excited with how well aligned with WebAssembly Glimmer looked at first glance. So we looked at Glimmer's architecture, and we noticed that the core virtual machine was a hot path that was written in very hand-tuned JavaScript. As a result, much of it didn't actually rely much on the features of JavaScript that aren't yet available in WebAssembly, surprisingly. So our plan was to migrate some of this internal code to WebAssembly. And after a few months of work, we've successfully migrated much of the low-level code in Glimmer to WebAssembly, as well as a good number of the opcodes in the VM. So how did it go? Well, as you recall from earlier in the keynote, having a path to land any experiment in Ember is priority number 1, which is why I am happy to report that the WASM branch of Glimmer is up to date with master and passing the entire test suite. So far, we have been mostly focused on compatibility, so we've been keeping the test suite green as we go. Also, as you know, Glimmer is the rendering engine for Ember.js, so keeping it green also means it works with Ember. In fact, we were able to get the Ember Observer app running by just swapping in our branch with no changes in the code, and the scheduling app is not only running with rehydration, it is also running with WebAssembly turned on. Unfortunately, we could not make this the real scheduling app because iOS broke WebAssembly temporarily due to a Spectre snafu, which will be fixed in the next few months. We learned this week.
Which is a fun thing to learn last night.
Yes. But nevertheless, this act does work in all browsers with WebAssembly. So to achieve its benefits, WebAssembly is a very low-level programming language, if you want to call it that. We didn't want to sacrifice the productivity of JavaScript and write low-level, unmaintainable assembly code. And thankfully, we're not the only ones who are very excited about WebAssembly. The Rust project is designed to help you write generally low-level code in a productive, high-level way. And the Rust project is also very excited about making low-level code accessible to JavaScript developers through the WebAssembly target. So the Rust community has built out a lot of infrastructure that is needed to build WebAssembly applications. And in fact, we have been building the WebAssembly branch of Glimmer in Rust. So we wouldn't want to hand tune it. Yeah, exactly. I don't have time today to get into the code, but here's a small example to show you that even though it's producing very low-level output, the code itself looks very high-level. And unlike JavaScript, the high-level nature of the code doesn't come at the cost of unpredictable performance. What you see is what you get. So what is the plan going forward? Now that Ember apps can run on WebAssembly, the next step is to land the branch behind a feature flag. We won't enable it until there are strong performance benefits, and we have also verified there are no unknown issues with browser compatibility and debuggability. As you can see, we wrote that sentence before we learned that iOS didn't work. But we need to make sure that it actually works. Interestingly, you might be asking, like, what about IE11, which is still a supported browser? There's actually a WASM to ASM.js backend that exists and works, and that we're planning on using to target IE11. So we don't need to wait to drop IE11 to add this support. Because we've been so focused on maintaining compatibility, we're currently doing some things in the code that are preventing us from taking advantage of the performance benefits. For example, to work with our existing test infrastructure, we're currently encoding the WebAssembly binary as a base64 string in JavaScript. Yes, the people who laugh realize how bad that is. This prevents us from getting an accurate assessment of the performance profile, so the next steps in the code are to clean up the known inefficiencies so we can get a better sense of it. The numbers that we got so far are decent, but nothing to call home about, but it is because of these inefficiencies that we need to clean up.
So both of us really value the fact that our community is focused on finding ways to take advantage of cutting-edge web technologies, but without losing sight of what really matters, which is building great apps that our users love over the long haul. Despite being 7 years old, Ember has never been more technically advanced than it is right now. And our community has never been more energized. We've already landed so much cool stuff, and only a fraction of it we've had time to share with you today. But we need your help to make sure that Ember remains the most productive way to build for the web. So I wanted to ask really quickly, anyone who is in the audience who has participated in a sub-team, whether it's Ember CLI, Ember Data, Learning Team, could you stand up? If you've been part of a strike team that has worked on the keynotes, can everyone who's on, OK, thank you. You guys do awesome work. I want to say thank you. Stay standing. I want to say thank you to these folks. You've poured your heart and your soul into building tools for other ambitious developers. Thank you so much for all of your hard work. If you are excited about any of the things that you saw today, these are the people to talk to at the conference. They would be more than happy to help you get started making your first contribution. So thank you guys very much. So whether this is your 5th EmberConf or your first, you are part of something special. This community is special. Oh my God. I'm so sorry.
Tom is tearing up.
This community is special. We have a really great lineup of talks for you this year, but this conference is really about the connections that you make with other people in the community. We are very, very excited just thinking about all the cool stuff that we're going to build together this year. Thank you and enjoy the show.